All right, so we're going to look at the orbit of Uranus. So we're given the information. The perihelion is 2.74 times 10 to the power 9 kilometers. Okay, that's the shortest distance. And then the aphelion is 3.0 times 10 to the power 9 kilometers. That's the largest distance. Okay, and this is how we calculate those, where A is half of the major axis. Okay, let's look at an illustration. And I should add E is the eccentricity. That's what we're looking for. Okay, so we're going to look at an ellipse. Okay, and the perihelion is the distance when it's closest to the sun. The aphelion is when it's the furthest from the sun. Okay, so those are the numbers. And this is how you calculate it. Okay, this is the major axis here, and that is equal to 2 times A. All right, and when you add these two together, these two numbers, you add those two together, you get 2A. Okay, so now all we need to do is calculate, we'll solve this system of equations, basically. All right, so you see you get 2A when you add those up. The AE's cancel. And so we have a number for 2A. We divide by 2 for A. Then that's pretty straightforward. Then we can just put that and we'll put it into this first one. We have A now. We're going to calculate E. Okay. Now, I did not write the units here. That's probably a bad habit. It's all kilometers. But here, the kilometers, the units are going to cancel, as do 10 to the power 9s. So there are no units. It's just a scale factor. The eccentricity is just a factor. And it's approximately 0.0453. In the answers, it says kilometers for units, and that's not really correct. There are no units. It's just a scale factor. Okay, there it is. Now, let me just point out here that this ellipse is not at all to scale. It's much exaggerated. So the eccentricity of this drawing is way bigger than that. Okay, with an eccentricity of 0.0453, the orbit is much closer to a circle. Okay, so this is just for illustration purposes. These distances are not that different. All right. Anyway, I hope that was helpful.